Welcome everybody to the Cloud Online Meetup. Today's topic is going to be how Dell and Intel are optimizing OpenStack clouds. And as OpenStack adoption accelerates in the enterprise, customers are evolving their infrastructure and operations environments to extract a higher performance and to optimize and secure services. And Dell, in partnership with Intel and Red Hat, are deploying optimized architectures to deliver significant performance improvements, security enhancements, and to enable OpenStack clouds to meet specified service level objectives. And in this session, we will outline the latest generation of Dell Red Hat cloud solutions and how we are extending our core architecture to leverage Intel Software Assurance Administrator to optimize service levels for OpenStack clouds. And today's speakers are going to be Steve from Dell and Alok from Intel. And a few logistics from up. The slides as well as the recorded sessions will be available roughly 48 hours after this session, so within 1 or 2 days. And in case you have any questions, feel free to ask those using the chat window on the left-hand side of your web panel. And with that, let me hand over to you guys, Steve and Alok. The stage is yours.
All right, thank you very much. This is Steve Croce, and I'll kick it off. So for today's session, what we're going to do is the majority of the content in the session is going to focus on Intel and their SAA product. But at least for the first portion, or for the first couple of minutes, this is Steve Croce from Dell. I'm going to go through our overall kind of strategy and how we approach bringing OpenStack solutions to market, and especially our more recent solutions that are a little bit more focused on the enterprise. So without any further ado, I'll charge ahead. If you have any questions, as Raphael mentioned, please submit them, and we'll take them all at the end. Okay, so as we approach OpenStack for the enterprise, really we've started to see a change in the market. Dell has been very involved in OpenStack from pretty much the very beginning. And though we've been working with a lot of the advanced and DIY customers for a number of years now, we're starting to see, and this is by no means a unique Dell thing, but an industry-wide thing. We're starting to see a move of enterprise customers wanting to investigate OpenStack and figure out how it can work into the enterprise. And so that's really where we're focusing today with Red Hat as well as Intel. And kind of the two themes we're seeing that are spread throughout these bullets are a lot more of the traditional look and feel of an enterprise solution, and so you want that validated end-to-end, very tested and tried and true solution. You want everything to be fully supported. You want a single throat to choke, somebody to call when you have an issue. You want some metrics and an idea of what the infrastructure will be able to provide you. You want that like I said, that traditional enterprise look and feel. Yet we're hearing that the real advantage why OpenStack is being investigated is to take advantage of the agility, the ability to provide self-service, the ability to be a lot more agile with the infrastructure and move more towards a service-oriented architecture, and also to be able to scale almost infinitely. So the real sweet spot and advantages of OpenStack, while still building around it the types of support and look and feel that an enterprise product usually has. And so despite those two stories we're hearing, we're seeing a little bit of a trend in the industry, and this is from both what we get asked for, but also from what some vendors are doing, is that we're seeing a lot of snowflakes start to pop up. And what we mean by snowflakes is everybody has a very, very unique way of setting things up, unique hardware requirements, unique software requirements, unique configurations. And as anybody who's worked with OpenStack before knows, OpenStack has hundreds of dials you can turn. And a lot of those dials depend on other dials. So once you start tweaking things, you end up with a very, very unique solution, which for service providers, that's all needed, and we've seen a lot of that in the past. But for the enterprise, what we're starting to see, and especially with a supported product, all of these snowflakes really starts to, it starts to hamper the stability of the product. Because once again, when you've got something, that only exists in one place and has not necessarily been tested in that exact configuration, it tends to be a little less stable. Repeatability becomes an issue. If you want to reproduce that exact same cloud in potentially another location, or if we need to reproduce internally, that becomes difficult with kind of this one-of-a-kind snowflake approach to standing up a cloud. The optimization's not there. A lot of those dials that I was talking about, you turn one, you need to turn a couple more to get things tuned. You need to tune the hardware to the software, and that's something that you're not able to do in a lot of cases for something that's a complete snowflake. Supportability becomes a concern. So if you call up Dell or Red Hat and say, hey, the solution is not doing what I expect it to, it becomes hard to diagnose problems when once again you've got a solution on the other end that doesn't match what you tested. And it makes it difficult to add on. Once you've got this very fragile setup, adding on new nodes, expanding to other regions, can cause some problems to occur. And so we end up seeing it as a whole big house of cards that can come down and may ultimately hurt the opinion and what people see in OpenStack as we go forward. And so this is by no means saying that we're trying to drive towards one single configuration to to rule them all, but what we're trying to say is, when you modify and when you change and when you add, kind of uniqueness to the solution, we're really looking to, and our goal is to find ways to do that in a way that's, that's tested and reproducible. And so, that's where we come back to our overall goal in our partnership with Red Hat that was basically announced a little over a year ago. And so we've been working between the two of us, Dell and Red Hat, to create a kind of solution that rounds the edges and really fills in the gaps for enterprise use cases. So it's got all the all the agility and flexibility and capabilities of OpenStack, but kind of makes a nice, well-packaged and tested and validated solution that's a little bit more suitable to what an enterprise user is going to expect. So it's enterprise grade, it's highly scalable and secure, and fully supported. You call up Dell, you call up Red Hat, we know exactly what you're running on site, and we're able to provide support. In many cases longer than the community does. Since there's a new release coming out every 6 months in the community. The other piece is we provide the ability to stand that up very quickly, the fulfillment, deployment, and support experience. So we can walk in, stand up an OpenStack cloud, provide the knowledge transfer and the training needed to maintain and administer that, and then after the fact be able to provide the support. So really that full life cycle capability. And then also start to look into use cases. So one of the things beyond the core IaaS cloud is the ability to provide some profiling and some workload specific configurations, which you'll start to see more and more on our roadmap coming up. The solution itself and the components included, I'm not going to go into exactly what the configurations are. We can handle that in the Q&A later. But it's just at a high level, as you may expect, there's Dell hardware included. So we use our PowerEdge servers. There is Dell networking included. And then also, given this, kind of making things a little bit more friendly for the enterprise, is support for things like EqualLogic, which is more traditional enterprise storage, so that customers that are EqualLogic users can tie that into their OpenStack cloud. We couple that with Red Hat's capability on the OpenStack side, enterprise Linux, their OpenStack platform, and even recent acquisitions like Inktank-Ceph. We use Inktank-Ceph Enterprise in the solution as well. We both provide services components. So we stand up hardware, we stand up software, and really provide support throughout as a joint initiative. And really the glue that pulls that all together is that reference architecture I list at the top. And I'll talk a little bit more about that in the next slide. And so these first four things I mentioned, those services at the bottom all the way around to OpenStack software, that's really the core kind of IaaS cloud. And so the next piece that we're also looking into, and you'll see more of this coming, is the extensions to the solution. So taking that core IaaS cloud and being able to add on capabilities that either fill gaps or provide extensions into features or functionality that once again the enterprise will need. And so that this reference architecture is much more, and this is really, like I said, the meat of what we're doing and the glue that holds it all together, is more than just a single configuration that we test and say, here, use this. It's our way of not only testing one configuration, but testing many of the modifications. We offer scalability within our reference architecture, and really get closer to what I had talked about earlier, is creating a reliable and repeatable OpenStack cloud. So things based on the RA and within the bounds of the RA are known working. We have the same thing running in our lab, so you have the ability to basically be running what we're running in our lab and what Red Hat supported. Red Hat's running within their labs as well, so that when it comes to supportability, we're able to help quickly diagnose and find any issues that you may run into. And we're also able to provide prescriptive guidance for somebody who may not have as hard a stance on exactly what settings they want, or what hardware configurations they need. We have some optimized configurations where we can be prescriptive up front to even just give you a starting point that you can then start to modify from there. And so once again, this is our goal, to be able to bridge that gap, to be able to provide a known, well-working, functionally validated solution that also offers the flexibility that you need to have the solution that meets your needs rather than just a single configuration. And those extensions, once again, we're looking at a number of areas, and these are by no means just Dell products or just Red Hat products or Intel products. We're looking, pulling many third parties into this. But for the purposes of today, we're going to focus on performance management. And that's where Intel's Service Assurance Administrator component comes in. So before I hand it over to Alok, I'll just mention that both parties, both Dell and Intel, and even Red Hat as part of the solution, we're all investing in OpenStack, be it in development, in kind of shepherding products through the process, in events, in providing kind of marketing support. So we're all involved and very much investing in OpenStack. We've all been invested in the enterprise for a while. Dell, in the hardware and even on the solution side. Red Hat on, in bringing Linux to the enterprise, and now OpenStack, and then Intel as well in providing, gear and solutions to the enterprise. And you'll see there's some asterisks here in under development. We're also working to enable SAA as one of those options that you can go buy, and it's just a checkbox add into the solution. So yeah, I want the Dell Red Hat OpenStack Cloud, and add in SAA. We want to be able to enable that very easily, but still make it an optional add-in, so it's not something that's compulsory. So without any further ado, I'll pass it over to Alok, and he can talk about SAA and what it brings to the table.
Yeah, thank you, Steve. I want to talk about what Steve mentioned, that we are working on this reference architecture. We have it up running in our labs. We're integrating our code components, and the primary motivation from Intel is to make sure that the industry can take advantage of all of the innovation that we put in our standard IE architecture, and we know that there's this general trend that we are helping with as well, which is the move to software-defined infrastructure. That is, we have enterprise moving from physical systems to virtual machines, and now trying to put a cloud services front end so they can automate and get that agility that Steve mentioned. And OpenStack being one of the open source solutions that people are looking to, so that they don't have a vendor lock-in. And so there's agility, automation, efficiency, so that they can move away from the static manual infrastructure to this automated, intelligent system. And each segment is taking advantage of this model in a different way. So the enterprise has moved to virtualization, is now looking to put a cloud services front The telco is looking to move some of their network function virtualization code. That is things like firewalls, load balancers from physical devices to virtual devices. And also, there's HPC segment looking to get more flexibility in their deployment, and also cloud service providers looking to enhance the capabilities and services and especially managed services or hosting services that they're offering to customers. So all of that is leading towards to software-defined infrastructure. And what we have done is taken OpenStack as an example to show how you can first of all create software-defined infrastructure using OpenStack, and how you can enhance it to take advantage of the performance capabilities. So what I will do over the next few slides is to show you what problems people face as they try to move to this, as we've talked to customers in these segments, and show you also how the technologies that we are developing as part of SAA will address those problems. The first problem that we heard, the two biggest problems, if you will, that we heard from customers were around trust and performance. So in trust, the problem is that now you're trying to run business-critical workloads on a multi-tenant system, and people want to know that the system on which these virtual machines will be deployed can be trusted. And so that's the first concern, that the systems have not been compromised. And the second one is around performance. That is, there are two problems here. One is, how do I describe what compute capacity I need from a virtual machine that I'm going to be renting from the OpenStack cloud, infrastructure as a service cloud? And then, how do I avoid noisy neighbors? And by noisy neighbors, we'll describe a little bit of what the problem is. Basically, one VM affecting the performance of another VM on the same machine, because that can create jitter in the performance of the application. So those are the two big problems we heard, and so we looked to address those two concerns, and we came up with a solution of how to make it easy and convenient to go enhance existing OpenStack solutions. So our solution consists of essentially three components in OpenStack. One is agents on the node in Linux that collect deep platform telemetry around performance and trust status of the system. These agents then talk to a service assurance controller, which is a virtual appliance, and it collects all the data and provides APIs for the world to access so that it can be easily integrated into existing IT infrastructure. We have a REST API to do that. There's also a web console, and I'll show you some screenshots from it that if you want to use our built-in web console, you can use that to get information about capacity and remediate any problems that you're having in performance. And all of this is connected to OpenStack with this simple Nova scheduler plugin, and that connects to the assurance controller, which allows us to place the workloads properly. Now, the challenges people are trying to address is, first of all, in a multi-tenant, multi-workload, your workloads may not get predictable performance, and how do you go debug that and figure out or avoid it if you can? There's also this limited trust on multi-tenant nodes. How can you generate additional trust in the systems on which you're deploying your software-defined infrastructure? And there's also this more intelligent workload placement. That is, the systems might be gray machines in the sense that you may have servers in your cloud stack that maybe a fan has failed. The temperature is getting hot. You don't want additional workload to be placed on that system. Default OpenStack algorithms don't distinguish things at that level. So our scheduler plugin might be able to detect that and then make sure that the new instances are requested, they don't get placed on those machines. And of course, it makes the overall scheduling of workload more efficient so that we avoid any system on which there may be a lot of noisy neighbors. So that's essentially just how our solution works. Agents on every compute host, a virtual appliance that collects the data and provides the REST API for easy integration, or a direct web console if that's what you want to use, and a plugin that sits on the scheduler. So, and additional information is available on our website. So now let me show you what's unique about our solution. Why did we go do this? So we the things that we are uniquely addressing with SA are threefold. One is to help the customer size what virtual machine, what size virtual machine do I get, how much performance capacity it needs, how do I specify that, and what's the best way to match that workload request to the platform capability and capacity. And we've come up with a compute metric, so that represents something that will translate well across generations of CPUs, and so that as you upgrade and maintain your system, you can still specify your compute requirements with that compute unit. There's also this other problem of, the hardest problem from an operation side is once you move to an OpenStack cloud and you've got some business critical workloads running on it, and because it's a multi-tenant, multi-workload environment, somebody calls in every once in a while and says, hey, my application is slow sometimes. These can be very hard to diagnose what the problem might be, especially if the root cause of these problems are these noisy neighbors where they are using low-level platform resources. Because those low-level CPU resources are shared. For example, cache, last level cache in the CPU might be shared. There may be other resources, memory bandwidth, those kinds of things that may be shared. And when one system, let's say it's a video streaming and coding application starts to stream, it's going to trash the cache and affect the performance of the next VM. And those are hard to detect because normal monitoring management solutions that are available in the industry do not monitor at that level. And that's unique capability that Intel can bring, and so we've put that in our agent in our controller. And the last but not the least is to make sure that when the system is booting up, there is a safe, secure way to make sure that the BIOS has not been tampered with, the hypervisor has not been tampered with, create a whitelist of all the BIOS signatures and hypervisor signatures of what's allowed to load. So these are the unique capabilities that we have done. Compute units, the ability to diagnose problems quickly, and of course, make sure that the security of the system is maintained. So, in short, the way the system works is that we help customers run workloads with confidence on the software-defined infrastructure by enhancing the machine flavors that are offered in the service catalog. So you can pick a machine that is with a higher performance requirement and a trust requirement. That's the first. Then, of course, we automate this whole process with our controller, so you can enhance the OpenStack to provision the machines and get the best performance and assure the performance post deployment as well with the monitoring tools. And we have the right APIs and things like that so that you can integrate with existing IT tools. So that's the high-level overview of service assurance administrative products. Well, and we have, as a general direction, we are going to open source all our components. It is not open source right now. So we're working towards that, and we can expect announcements soon. So let me give you a little bit more flavor now of how it actually works with screenshots so that you can better appreciate what the problems we're trying to solve. So some of the key problems that people face when they're trying to deploy a cloud is the first problem would be you have a compute node, you just don't know how to specify the compute capacity of that node, how to determine that, and also if there are virtual machines that are being requested, how do those things get sliced up. So that's one class of problems. What metric to use to specify the total capacity of a node, what metric to use to specify capacity of VMs that are running on it, and also you may have other components on the system. You may have services running in the Linux, or you may have some step workload for your storage running in the Linux, or some other applications running there, and of course you have the virtual machines as well. So all of this needs to be balanced, and you have to be able to quarantine how much resources the services use, how much the VMs use, and to make sure that there isn't an interference. And when there is an interference, you need to be able to identify the pool of systems that are interfering with each other, and then take remedial action. Move, maybe evacuate the noisy VM, or evacuate the other VM which is being affected. So those are all choices that the administrator faces. So I'll drill down a little bit and to tell you, to show you what we have done and what we mean by these elements. So an example of a noisy neighbor, this illustration on the right, which shows all the VMs and hypervisor. You can see that in a CPU you may have multiple cores. All of those cores share some L3 cache, and as these VMs start to execute, they use up some portion of the cache. And what can happen is that if you have a VM that is very cache aggressive and maybe streaming video or something, or video frames or video frame processing, it can crash the cache and have a severe impact on the performance of the next VM. So that's what we mean by noisy neighbors and a contention pool, being able to identify which nodes are causing contention and where is so that you can take a remedial action. The icon there, the speaker, is basically a noisemaker. The listeners are the ones that are being affected by that particular aggressor. So that's an example of noisy neighbors. So you understand what we mean when we say that. Now, I mentioned that as a operator, you have to be able to define some compute unit so that as you maintain multiple systems. vCPU, which is often how people describe things, on an older generation processor, it's not the same as a vCPU on a newer generation processor. So specifying requirements in terms of vCPU is not sufficient. And what we have, done is define a service compute unit metric that is more dynamic and is more portable across CPUs, so that we can help both the operator and the person setting up the systems make a better job of determining how much capacity they have in the nodes, and then as it is sliced up to particular VMs, how to help the customers specify what they need from the systems. So that's one innovation in the product, and our product does that by actually our agent does a little bit of benchmarking and investigation of the system. We collect all kinds of information from the system, the number of CPUs, cores, frequency, cache size, things like that. And based on that, we are able to come up with the the total capacity of the compute unit. And of course, as VMs start to run, and those VMs specify, reserve or burst in service compute unit capacity, those are taken away from the total available and then shown to the operator so they can take better, do better capacity planning. Similarly, we've mentioned the noisy neighbor problem. So the noisy neighbor problem, we do things like cache log, cache monitoring, so we can tell how much contention is happening on each system, and then help identify that contention pool of systems, and even identify potential aggressor or aggressors on a single system. So the other kinds of innovation that we have done is the ability to let the user specify the machine flavors that customers can buy. So the standard AWS style machines would say how many vCPUs, RAMs, etc. What we do is enhance that machine flavor definition. So customers can come in and say, not only give me those things, but make sure my compute capacity is range 1 to 2, meaning 1 is guaranteed, 1 service compute unit, we may burst up to 2. And also make sure that VM only lands on a node that is trusted. That is, when the system booted, its BIOS was checked, its hypervisor was checked against the whitelist, and you said, yep, nothing was tampered and the system's coming up fine. So this is an example of a capability that is in our product right now, but we are also, we have worked with the open source community and upstreamed a lot of these capabilities, as part of the Graffiti project in OpenStack. So that is the general direction that we will be taking, which is make sure that the industry gets enabled to take advantage of the capabilities of the platforms. So that's an example. There's also an example I just wanted to show of enhancing the machine flavors with core assignment. So if you have some important workload, just assume that somebody, a telco wants to run network function virtualization workload. They should be able to specify a core. That is, do a core pinning or core assignment. But my VM should only, be dedicated on that particular core. And that's the type of capability, so that no noisy neighbor will come up, and we understand it will be able to run with assurance on that node. So that's another example of a machine flavor enhancement that our Service Assurance Administrator product allows. And of course, the product has all kinds of screens and things in our web console, so you can look, if you take a summary view, you can look at a particular node, or you can start with a virtual machine, and see how much it's using. At a node level, you can see how much is being used by the operating system, what resources are being used by the operating system, and application and services that are running in the operating system, and also what's being utilized by the virtual machines. So that's some of the elements on the performance side. I mentioned core pinning. There are some screenshots here that shows how we show it in our web console. We have a little pin icon that says, okay, this particular VM is pinned to a core. And we have this little icon on the left, if you look at the thing that looks like a log, that says that particular node is a trusted platform. It has the Intel TXT technology. It has the trusted platform module, TPM. And if the platform has those capabilities, then you can implement the trusted attestation. Make sure the system is booted. Make sure that if a workload needs to run only on the trusted system, we'll pull it on that. And if necessary, if there's core pinning required, we can pin the core. Or if there's a general shared system for generic workloads, they can be have some SLA, and we can identify when there is a nosy neighbor or noisy neighbor with those little icons. If you look on the left, with the speaker being the noise, to indicate there is noise there or it's being affected by noise. So this is how we extend the basic capabilities, things that are hard to debug and find you through using generic monitoring management solutions. And so with that, let me move forward to give you an idea also from a screenshot perspective, so you can see what's available in the product. We of course collect all kinds of information, log files, things like that from the node, so it can help the operator diagnose the problem. One of the big benefits from our product is, of course, being able to identify the pool of contending pool of systems that are either creating noise or being affected by noise, and identifying which is the aggressor and which VM is suffering from in its performance. So let me just summarize the kinds of things that we have introduced recently in our product. Number one is this compute throughput metering. That is, you can specify service compute units for to characterize the node's capacity, to characterize the utilization of resources by each VM. There's also a host and application service assurance, so you can create a quota on all of the host applications and services so they don't affect the VM performance. This may be more interesting if you're running things like Ceph on the same node as you're running some of your IaaS or NFV workloads, network function virtualization workloads. There's also contention-aware scheduling. Our algorithm is enhanced so that it knows which systems have a lot of noise, which ones do not, and so we can prioritize the nodes and then make sure that every time a new node, new VM request comes in, it lands only on a system where there's the least noise and the most likelihood of good performance, both at the initial placement and then, like I said, post-initial placement, we can show the noisy neighbor and help customers migrate the systems. There's also the gray machine avoidance. That is, if we use IPMI, the Intelligent Platform Monitoring Interfaces, so that we know the system is not in a healthy state, and we have algorithms to say avoid systems that are not in a healthy state right now, so that both at the initial placement you will make sure that your VMs do not suffer. And then, of course, not the least is the trusted compute pool. That is, make sure that nodes only land on trusted compute pool, and also generate log files and reports so that you can comply with IT requirements that, look, this VM only ran on trusted nodes in its whole lifetime, and here's the record. every time the system booted, there's a log file and that shows that the system was on a trusted node. So, so essentially that's the summary of the capabilities that service assurance brings in over and above what is available in the standard OpenStack community. And as I mentioned, our general direction is that we will open source our code, and we will try to get most of our technologies into the OpenStack blueprinting process and make sure that that code becomes available, or capability becomes available as part of the community. So with that, let me just flash a little bit of our legal notices so that I have done the obligatory thing. So with that, Steve, do you want to come back in and
Sure. I think we've got our resources and contacts you can see on the screen here if you wanted any further information. But I think at this point, Alok, we can kick it over to questions. And I see in the chat window there's actually a couple for you right now.
Okay, yeah. And
Thank you so much, guys. So let's read out the questions loudly. So first one is around the Intel plugin. Is it available today already?
Yes, the Intel plugin technology is available today, and you can go to the intel.com assurance and contact us through that, and we will respond how you can get it.
Great. The second question is, which OpenStack distro does it come with?
It supports, up to the most recent version, up to Juno. So we have. So if you request on our website, we can let you know all the versions that we support and the combinations of platforms that we support.
Okay. And do you have any deployment in production already out there?
We have some POCs in deployment, and we have some channel partners that we are working with to get the solution deployed. They are mostly in the early POC stage.
What use cases are you targeting with your solution?
The use cases are essentially those noisy neighbor kind of scenarios where customers have occasional performance problems. It may be caused by the nature of the workloads that aggressively use Intel platforms, like cache and other system resources. So these are performance management, performance issues with compute nodes. And also, I mentioned the ability to pin your VMs to particular core so you can basically avoid performance issues or guarantee performance for a particular workload.
Okay. Can you guys talk a little bit about the road ahead? What plans do you have for your joint solution?
Yeah. So, so we as Intel Service Assurance Administrator team, like mentioned, our direction is to open source our capability, make sure the capabilities becomes part of the community. So that's from a strategic direction perspective. We're working with Dell clearly to make sure that our solution gets validated with the Dell reference architecture, and we're working with Red Hat distribution. We support one version of their Red Hat, and we will continue to work with them as they upgrade their OS distributions. We will work with them to stay up to date. So, Steve, do you want to add anything to that?
Yeah, I think the only thing I'd add is that as I mentioned before, we both have aspirations of making this kind of an SAA a standard offering or a standard option within our solution, so that as you're kind of looking at the the menu of what's available, we're able to offer SAA as something that's part of the initial deployment. So when we come in and stand it up, SAA gets set up at the same time. That's part of the test and validation matrix. So it's known working. We know the pitfalls. We know how to, we know we've characterized it well, and that it's kind of tied into the support as well. So as it's supported, it's obviously no surprise to anybody along the chain if when there's a support request for SAA. So we'd love to make it, and we plan to make it ultimately a part or of the solution that each customer can decide whether they'd like it or not. So that's ultimately our plan.
There's one question regarding support for Docker. Do you guys support Docker with your solution?
So we do not support Docker at this time. We support KVM only, or Linux.
And I guess on the Dell side, I can answer that question as well. We support Docker within OpenStack as much as OpenStack supports Docker today. But one thing I will say is it's not it's not yet a fully baked in piece of our solution, integral part of our solution today. Though we do plan on tying that in.
All right, guys. Thank you very much. Sorry, go ahead.
One additional thing, just because somebody had asked about which version. So we have worked with, we have supported Havana, Grizzly. We started with the support for Grizzly. We have supported Havana, Icehouse, Juno, and of course we're working towards making sure we are compatible with Kilo and subsequent releases, just so for the person who asked.
I see there are no further questions from the